working up at Lake Forest Hospital.
Cool. Are we opened up, Madison?
We are opened up.
Okay, great. And everyone can see my screen, I think.
Yes.
Awesome. Recording started, so I guess we'll get going here. Thank you everyone for joining us today. We have a great presentation panelist discussion about what architects should know when designing glass facades. This is sponsored or being put together with our Technical Issues Knowledge Committee. My name is Lee Fink. I'm an architect and facade consultant actually with Socotec. And before we start, we just wanted to thank our 1869 Circle partners that are supporting AIA Chicago listed here. And then more specifically, our Technical Issues Knowledge Committee sponsors, which is from Vitro Architectural Glass and Socotec Engineering here. As you probably saw when you registered, we have learning objectives. Really, the biggest thing is, giving the architects the tools and knowledge of what to consider when designing for glass and knowing the risks associated with different types of glass systems. We have some great speakers today. Brandon Hall is a principal at BHA. He's an architect. Alex Barmas, senior associate at Socotec. He's going to be representing the facade consultant. Andy Hill, the CEO at Glass Solutions Inc. And a glazing contractor. So we have really great widespread expertise. I'm sure with different opinions, and we'll be talking about the different topics and their perspectives on each one. I will just say this is a AIA accredited course. So if you registered and put your AIA number, you will get the credit for that. And then if you have any questions, please feel free to type them in the Q&A text, Q&A box. I think it's on the bottom or top of your screen. And just type that in and we'll have time at the end of this presentation to answer any of those questions. So we'd like to start with just introducing a little bit more about our speakers, and then we'll get into the panelist discussion. So Brandon, if you want to kick it off and kind of talk about you and your experience, go from there.
Can you hear me, Lee? I'm sorry
Yep.
that my internet, of course, is starting to cut out right as
No,
doing this. But hi, everyone. My name's Brandon Hall. I founded a practice about a year ago named BHA that's still very much in its incubation phase, focused on cultural, institutional, residential projects. Lee, feel free to keep clicking. Prior to founding that practice, I worked at Wheeler Kearns for 5 years, and before that, Studio Gang for 3, most notably where I was the project architect for the Vista Tower. I just wanted to highlight a couple of glazing projects that might shed light on the kind of different contexts that I've worked in, because I think that's really where I can bring value to this conversation. So these are pictures of the Momentary, which is a cultural institution in Bentonville, Arkansas, done with Wheeler Kearns, that has a variety of glazing systems on it. You can keep going, Lee. And then, anywhere from a lot of these are steel veneer systems, but we used storefront and some other systems, all like really small scopes, but using artist installations to on the glazing. Prior to that, I was the project architect on the Vista Tower. So that was a totally different context, looking at working a totally custom system, sourcing glass from all over the world to create this gradient, and then working through the kind of performance and technical issues. And then lastly, this is Solstice on the Park, which was done with Andy, with Studio Gang. And this was a system where Andy kind of did the fun front part, and then we used a kind of more readily available commercial system on the back. So that was just a totally different context where we had a kind of set of ideas, and then Andy helped or really brought that vision to life. But looking forward to the conversation. Thanks.
Hi, everybody. I'm Alex Barmas. I'm a senior associate with Socotec right now. I've kind of been all around the world for a little while. I was even a curtain wall contractor, so I worked for Enclose for a period of time. But the last 5 years I've been working with Socotec. I was the principal facade consultant for One Vanderbilt. Some of the projects, and I've kind of put up projects that were very glassy and all had very different glass issues on this page. So a couple of projects with Renzo Piano with very complicated glazed skylights, the sliding doors for the Apple headquarters in Cupertino, which had probably the biggest glass I'll ever get to work with on there. So I've worked with a lot of challenging glass issues.
How tall is that glass, Alex?
I only remember it in meters. It's 15 meters tall, and 3.25 meters wide. It's actually post tension. There's a tension rod between the glass lights within the laminate. Anyway, so I've done a couple of really interesting glass projects, and hopefully I can bring some of that to bear in this discussion.
Thanks, Alex. Yeah, Andy Hill, Glass Solutions. About 25 years. I started at Harmon, and soon after that, my dad founded Glass Solutions and came to work for him. And then since in about 2012, 2013, took over as CEO. Our emphasis is design, build, design assist within in humidified buildings, specialized in hospitals and higher education. This here's a 4-building project in West Des Moines that we just recently finished. We did all of the glass, obviously. We also did the cane mail on the parking garage. It was a product that was from overseas, as like a woven chain, almost kind of like a perforated area, or a perforated panel, sorry. And this, again, it was design build with RDG Architects out of Omaha. Had good success with them and hoping to do some future projects with them out in that area. We did the Willis Tower that was shown on the project in the very beginning. We fortunate enough to work with Gensler on that. This is a night shot of the connectors. Pretty neat building. How it the look of the glass changes day and night. Then I think, what was the last project we threw? Oh yeah, we did. This was Rubenstein. It's interesting. This was done with the true bird glass, if you will, Ornolux from overseas. But this was a very almost 2.5 years of pre-construction. Really interesting building, great partners. So Andy Hill Glass Solutions. Thanks, Lee.
Thanks. So yeah, I guess we'll just get into it. I know we have a lot of architects here listening in, and if you could tell these design architects, what are some of the biggest considerations they should know of when designing glass for new construction. And I know maybe we'll start with you, Andy, just to keep the flow going, and then Alex and Brandon can chime in.
Yeah. I think the biggest thing typically that we see is understanding what the glass sizing capabilities are as it associates with the budget. As I always tell everybody, is try to maximize your glass and minimize your metal. And what that allows you to do is obviously, just like this here that we didn't do this, but this is the basketball court at 167 North Green Street. And here, you have big lights, so 5 foot wide to probably just under, 10 foot tall. That 50 square foot is about the threshold that becomes manageable for pre-glazing, manageable from a price perspective. Obviously you can get much bigger, not saying that, but it's that 50 square feet is right on that threshold of the quarter over quarter versus 5/16 over 5/16, or even getting into 3/8, when we're dealing with flatness. So as the first consideration, that's what I usually try to look at. And see what the feel is that 50 square foot area.
Alex is a facade consultant with our really telling, design architects early on, to consider.
Yeah, I think what Andy brought up is absolutely right. There are always, depending on the building typology, real sweet spots in terms of glass panel dimensions for commercial projects. That 5 to 6 foot range is a great sweet spot for panel size. The other thing that really is important, as the energy codes become tighter, maximizing center of panel area becomes so much more important. We're really coming up against framing limitations on all of our projects, and the more we can minimize, the more we can get the aspect ratios relatively square and chunky and minimize the amount of framing, the more efficient we are for energy, not just for cost. So it's a great point there. Obviously, when we're doing residential projects, we start hitting weight limitations very quickly with larger panel sizes. So, commercial, I think, is very much in what Andy is saying. For residential, there's a different typology there, and we're really forced to limit by what we need for operable vents. And you're looking at trying to stay within 140 pound, 150 pound sash weight for an operable sash. And that, especially when you get into thick glass, triple glazing, 5/16 inch outers for flatness, you hit that threshold very quickly. So that's the only place where it's very different, I think.
And Brandon, how about you when you are starting up even concept? What are you thinking about?
Yeah, I'd say, one of the things that I always think about when starting a project is just like how you're going to come to the conclusion from a procurement standpoint, whether the design intent requires, a lot of bespoke custom profiles from day one, or if something, a commodity off the shelf product becomes the kind of thing you're going towards. I think it's interesting, I've certainly done the projects both ways where, with the help of a contractor doing pre-con, you can kind of go directly and start working on a system that's maybe more typical with a glazing contractor versus a truly bespoke system where you're, involving a facade consultant and then hoping to get somebody on pre-con to do a lot of those quick things at the beginning to kind of establish systems and logics. So I'd say really the procurement is a kind of key part of how to approach a design project like this.
Yeah, that's a great point, because too often projects get behind very early on because of, to both the points is, depending on the modular and without doing some initial structural review and understanding what systems will work for the building, window wall versus unitized, cantilevered versus, deck anchor, things like that can make huge swings in your procurement. And as we all saw a year ago, things are getting much better, but as we saw a year ago or so with metals, we never know what's going to happen from a procurement. So that's a very good point, Brandon.
Yeah, I was going to say, I'm sure, we run into budget and performance requirements early on in the design. And those are, starting to set the course of what you can and cannot do. Andy, just as from a contracting standpoint, can you give us relative ballpark of what we're talking about in terms of price per square foot of a, commodity versus, bespoke versus ultra bespoke, I guess?
Yeah, I mean, it's not uncommon as, and I'm not sure the entire, but, some of the apartment buildings, you're going to see, square foot numbers, somewhere in the, for window wall in the, $80 range, maybe even a hair cheaper, to what I would say is kind of some standard cantilevered curtain wall in the 125. And then, we're at, in the 175 to 200 in most of our hospital work that we have going on here locally and across the Midwest. Once you start putting in the back pans and some architectural panels or opaque areas, shadow boxes, things of that nature. So, you're talking from one to the other, an easy $200 swing.
Right, so yeah, you could easily get over, double, if not more, triple the cost of
Yeah.
the same system. If you,
Yeah, and like Alex said, I mean, you start getting into triple glazing, which we're starting to see, and we're starting to see a lot with this. The thermal is just getting more stringent on the hospital jobs. It's not uncommon to see mid-30 numbers, even trying to push 40. It's crazy.
well, this might lead to the next question here. What kind of process of procurement would you recommend to architects design for more complex glass systems?
Brandon, take this one. You've had enough recently.
Start, yeah, Brandon.
Yeah, I mean, I think that, ultimately this boils down to coming up with an intent and then figuring out how all these pieces come together. I mean, I think in the course of kind of prepping for this call, we've been talking a lot about how mechanical engineers, structural engineers, they all kind of come to bear, particularly on mostly glass projects. And so I think that, you kind of need an owner to buy into maybe not trying to competitively bid a total glass system. If you got to find the right partner, and having that right partner on board early will pay dividends in simplifying structural design, simplifying mechanical design, where you're not getting into a bid phase and you're needing to recalibrate everything to a new glass manufacturer. I mean, I've done it that way, and it's a little bit challenging, but I think, yeah, just trying to come up with a strategy with an owner, getting buy-in to say, hey, we need a facade consultant early on, we need a glazing design build, design assist contractor early on are really key to kind of getting to your right solution.
Yeah, I think robust performance specifications help. And again, it was something we talked about in the build up to this process. Because the procurement landscape is really complex everywhere where we work, there's no guarantee that all of your bidders are going to be procuring domestically. There's also no guarantee that all of your bidders are going to be procuring from Europe or China. But the best you can control is to write a clear understanding of what performance is required for the project. And then when you engage that design assist partner, they can work from that understanding, and it becomes a lot simpler typically. So define well the things you can define, and there does have to be a little bit of, and I think that's the hardest thing for owners often to accept, is there has to be a bit of fluidity left, because your partners aren't always going to have the same sweet spot. So what Andy's sweet spot is for panel size and installation methodology isn't necessarily the same as somebody else. And we want to be sure that we're not writing specs to match one person or a previous project without considering the fact that things do change depending on who you're working with. And it's hard. It's not something, but ultimately it's because the industry that we're working with isn't mass produced product. It's systems and components, and everything is a bit custom, even for the most basic system.
Yeah, I mean, I don't know that you could say it much better. I mean, having the proper design narrative laid out early on is essential to that initial process of, getting the model, start working in the model, running thermal, sizing the mullions, depending on the tributary with, understanding the glass, and again, that design is knowing, your indoor, outdoor, your RH, all of that is going to allow you to properly design that facade right off the bat, which is typically the longest part of the process. And if you can achieve that up front, whether you're dealing with custom products or, proprietary systems from one glass company or other, or you're using commodity product, you still need that up front to give somebody like ourselves or another glass company, the opportunity to assist the architect in designing that wall.
So are you guys really seeing a lot of this being front end work and concept and ST, where design architects say, I have this rendering, this is what I want it to look like. Here's our outline spec or narrative of how we want it to perform. Here's our budget. Can it work? And sometimes is that kind of the recommendation, is to get up front and then kind of give that kind of yay or nay kind of a feeling to it.
Yeah, I mean, we're seeing a lot of that right now. The last two jobs locally, UCM, the new cancer center, and then AH, both of those were awarded on an RFP with renderings. We're looking at some stuff out of town, hospital and university stuff, same way. But yeah, the renderings, narrative on, to Alex's point, on a design spec, I'm going to say simple, but very strategic and thorough design initial narrative. And then that way we're able to put a GMP, if you will, based on the different facade types. But yeah, they're trying to get people awarded. The architects understand the time constraints, and they're trying to get specialty contractors. And a couple of these jobs, we're seeing ourselves get awarded prior to the MEPs, which never used to happen. And as we talked about preparing for this, they're trying to put more emphasis on the facade, because I think a lot of people are realizing that if you don't put the emphasis on the facade and that suffers, then you're going to have to try to do it with mechanical and electrical blind, all kinds of, and that can get into such huge costs that it upsets the project. So we're learning that the facade is the first big chunk of it.
And another, I guess, with procurement, we want to talk about schedule, and maybe Brandon, do you have any experience of, I've heard, you can potentially do early facade packages or something to get ahead, especially the past few years with the volatile market. Have you seen different types of procurements like that to make sure that, you get the material in?
Yeah, I mean, anecdotally, I had this kind of a similar experience on a smaller, not everything is a big hospital job, right? So, but if you're trying to the Momentary is a perfect example of it's a 65,000 square foot total building, but with about 3,500 square feet or 5,000 square feet of additions. The scale that I was working at there is much smaller, but even then we redrew between a veneer system on steel mullions and an aluminum T system 2 or 3 times through the process. And it really became a question of what the glazing contractor that the general contractor wanted to use was capable of. So I'd say that that, and it drives so many things, from slab edge locations of structure, of the way that you're feeding mechanical systems. All of these things are really impactful. And so I'd just say that, yeah, from a procurement standpoint, when you're early on, you have a really bold vision of what this thing needs to look like. I think getting in front of it, getting owner buy-in to be able to start that procurement process, finalizing your system selection is really critical to a successful final product.
Yeah, that's absolutely true. I'm working right now on a relatively small hospital project, and it is in some ways very challenging because you are very hamstrung by a smaller bidder pool, standard, like how they can modify and manage standardized pre-tested systems. So if we're talking about a procurement schedule, that one is 10,000 vertical square feet of curtain wall and punched openings, which is a legitimately decent sized project, and it has a 12-month from handshake to panel on site schedule. But that means no performance mock-up testing. It means a very constrained design assist schedule. So, I think you really need, exactly what Brandon was saying. If you don't have that alignment early on in the project, it's very hard to make up the schedule later when you do figure out that your pool of available subcontractors can't do the thing that you wanted to do because the typology of the job doesn't fit, or the square footage doesn't work, or they frankly just don't have manpower or factory slots for your schedule. And because we're not a commodity market, we're always going to be affected by that. If Andy's factory doesn't have slots for production, there's nothing that he can do to make it work. So he falls out, and then you're left with a different makeup of market. So exactly what Brandon was saying, early coordination is key with procurement of glass systems.
And if you, Lee, if you actually flip back all the way to the beginning, I don't know if it's simple, to the repositioning project at Willis Tower. And just to touch on what Alex said, it's really key. So this is a project that we were involved in from the get-go, and majority of these units that you see here, just look on the west, on the Wacker Street side, we actually designed those are like 34-foot tall units. And we did that so that we could just dead load down to the foundation, and we didn't have to anchor back to the second floor deck, and it allowed them to save a fair amount of money in the steel and the lighter weight decks, because we just used that as a lateral load. And then we went up and we tied back again laterally to the roof deck. So, to both of their points, bringing on, and again, this is a 20, I don't forget what it was, 25, 30,000 feet of curtain wall, but it was very strategic from an architectural standpoint, but also from a financial standpoint in an urban environment, to get the biggest units that we could, but also to save as much money from a steel perspective, because they had to erect all the steel obviously inside that area that you see, and kind of build the steel around them. So to Alex's point, it's not just always about just the glass, it's about the other trades that are following after, and the overall budget of the job.
I'm sure the structural engineers were pretty happy to hear about that too.
We gave TT a challenge there.
Those are all great points. Let's move on a little bit here. And then maybe this goes right to the next one. What are some structural design considerations architects should know about when designing glass systems? You talked about the ability to, kind of double span and reduce some of the, where dead load versus wind load anchors would be, to help the engineers. Are there other considerations architects can think about when, from a structural aspect?
Yeah, the biggest thing for us is just understanding what the opportunities want to be on where you want to stack. If it's a vertical job, where do you want to stack the units? Is it deck to deck? If it's an apartment with a slab edge cover, is it going beyond the slab? If it is that a top of slab anchor? Is it a face of slab anchor? Can we cantilever that unit up above the deck a couple feet? Like here's a glass slab edge cover there on the right. The other one on the left is, basically that is a deck to deck. That's a unit wall that's going in front of the slab. But understanding what you're trying to do with the vertical sections is huge from the get-go, because that allows us to design the proper system, whether it's just as you're seeing here, whether it's curtain wall, window wall, or now we're in the hybrid systems. You're starting to see more of this window wall and hybrid on office buildings. You're seeing, it's going up a lot in Nashville, a lot in New York, not so much in Chicago. But you're starting to see a lot of that, and that allows for the concrete versus steel, but still is beneficial with steel. But again, it allows your bent plates to be different. And these are all associated costs with people outside of the facade. And again, all of that adds up to the overall GMP. So it's really going back to the very beginning. What Alex said is knowing what your mullion width is, knowing what your spans are, and how that's going to interface with the deck. If it's going to go by, then what's the fire safing look like? What's that containment? What do we need to, obviously if it's an apartment or it's deck to deck, we're looking at sound and slab edge covers and finishes up at the ceiling with a receptor. So there's a little bit more going on there. So, and then obviously your stool trims and things of that nature at the floor lines. So.
Yeah, I think that's a good point. I do want to say, I've repeatedly gone through projects which have gone from window wall to curtain wall or curtain wall to window wall. So everything is absolutely possible. It just, the earlier on in the design process you settle on it, the easier the changes are. I think that's very possible if you're talking about untensioned concrete slab, or you're talking about composite steel deck. That's a little bit easier. A lot of Chicago work is post-tension slab, and that becomes a lot harder with a post-tension slab to make these kind of changes. And I think coordination is very difficult if you want to switch systems with a post-tension slab typology. But I think to some extent, all of these systems can be traded. Aesthetically, they obviously look very differently. It's very hard to get that 500 Lakeshore Drive look with a window wall system. Let's say it's impossible. There are ways to start to approximate it, but they don't work. So I think that the rendering, the elevation really matters at the early phase of a project to figuring out what your typology is going to be. Right.
And what you're structurally capable of, I guess, too, when you're figuring out.
Yeah.
Engineers, want the slab to be or they don't. So, Brandon, I'm guessing that's similar early on. You have to really bring those two trades together, huh?
And I'd say, like, for those that aren't as familiar with what a curtain wall is, what a window wall is, the curtain wall basically sits in front of the structure. The window wall, the glazing system sits on the structure, and a hybrid is sort of like the glazing system sits hanging on the structure, but it's a little bit in front of. And I think at least my understanding is in the Chicago market, and Andy, of course, correct me if I'm wrong, there are different trade and OSHA rules around the way that you put these systems up. And so it also has a cost impact where a window wall can be set in a different way that's more cost effective than a curtain wall from just keeping people safe perspective. And that all kind of plays into the things that Andy and Alex are saying in terms of budget and coordination is really like comes down to setting the units at the facade.
Yeah.
Yep. I mean, that's, and like the 500 to that point, that's kind of like, and some people on the call mean, the Talon wall that, that Chicago Heights, or that they came out with. And we did a similar product at the Grand Amway over and with a unitized wall. So to Brandon's points, you can manipulate the systems and to Alex's point, you can manipulate the systems to do what you want, how you want, from an architectural and a performance. We just need to know what the intent is and the
And I
budget.
think, Andy, the acoustic stuff is really important. It's obviously easier with a window wall than a curtain wall, just because you have that mass of the slab. So that's just another one of these considerations is fire, is acoustics when it comes to selecting a system.
Good point. Good point.
The counter problem with the window wall is it's harder to get more insulation in front of the slab edge. So there's a little bit of trade-off. Typically the curtain walls get better thermal performance than window wall systems.
Yeah, I guess that was just one slide we were going to talk about, is actually, in terms of the relationship to the mechanical systems, and what should design architects really be thinking about when they're designing the facade, but also how does it influence the mechanical systems? And it sounds like, Alex, you're saying the curtain wall is typically better performing.
Well, I think that's look, it's a huge item right now. Managing solar gains and managing U values of managing the thermal and solar performance of a facade is a huge input on energy. A lot of the projects that we deal with, there's not, especially like if you're doing commercial, there's not much on the load side that the mechanical engineers can remove. So they optimize their systems up to a point, and then they need to pull performance out of the building envelope. And I think as the energy code advances, and what we're seeing in a lot of other jurisdictions, most recently in Massachusetts, just complete overhauls of the energy code, basically forcing triple glazing throughout and forcing very stringent U values on the building envelope. And that, if you want any kind of glassy facade, is something that we all need to be facing going forward. At the same time, there's a lot that can be done. But like everything else we've talked about, early study and early knowledge is very important. So getting realistic U values for the module and type of system that you're actually planning on using on your project is very important. Just saying, going to the Wausau catalog and saying, well, Wausau says this window wall system gets like a 0.32, and plugging that in to what the mechanical engineer is going to use ignores, all of your operable vents, all, the modulation of your system. It may be better, but it may be worse. And that's something that's very hard to deal with when you actually start getting thermal calculations back from your facade contractor. So we keep coming back to like early coordination is really important.
Yeah, and again, the other thing is people tend to forget that the bigger the glass, the harder it is for the further away that center of glass is. And so when you're talking about thermal, it's measured center of glass. And so as you get back to this, go from the mullion to the center of the glass, if it's a 7-foot unit, there's a lot of work that has to happen on the inside of the building to warm that when it's -10 outside. So when the units are smaller, you can obviously that center glass is different. And again, depending on the glass thickness, your gaskets, all of that stuff has huge bearing. And then even just the glass color alone, a triple silver versus a standard low E, obviously that solar heat gain is going to be big difference, but it's a big difference aesthetically too. So like Alex, working with somebody early on to start figuring out what's more important, the color or the solar heat gain, because that's going to ultimately affect that wall from a performance level. And again, you know, from what the mechanical systems are going to have to do to wash that glass to balance it if it's not getting what it needs to have on its own.
That's a good point. And maybe that gets to one of our topics is like, what are some of the trends you're seeing? I know, you know, there are triple insulated glass, vacuum glass, other you know, materials out there. Or Brandon, are you seeing, you know, things like vacuum glass being used or triple insulated being used more often?
Yeah, definitely. Even in the residential sector, we're starting to see, you know, the kind of European PVC products. We're seeing a lot of vacuum glass, but I think that the, you know, coatings continue to get more advanced. You know, glass makeups are continuing to get thicker, which does have an impact in design.
Can you talk about what vacuum glass is for those that maybe don't know?
Yeah, so vacuum glass is where there's a very thin, say you have a typical insulated glass unit where the glass is here and here. Vacuum glass places a third very, very thin layer in the middle that acts as additional insulation. And so that oh, there we go. Andy's got one. So these glass units, like a typical standard IGU would have, you know, maybe you're in the point 0.2 U value, 0.25. I think these units are starting to get in the low teens.
Yeah, they're about, starting at about 14.
And so, like, you know, the energy codes are going to get stricter. I've always thought that, you know, from the outside that we'd, you know, maybe done our last all glass building, but I think some of these technologies are continuing to make it possible, but it is more challenging, more expensive than, you know, a lot of the stuff that you saw get built in the last 15 years.
Yep.
And Alex and Andy, do you want to even try to touch a little bit about our bird friends here?
Yeah, it's you know, it's like I say, we got to deal with it at Rubenstein down at University of Chicago. That was Ornalux, which is kind of the mothership, if you will. You know, Viracon, I was just on the phone with them this morning. They, you know, it's ever changing, trying to get it from the one surface to the two surface. You know, it's predominantly on the two surface right now. You're seeing a lot of laminated products, but it's everywhere. We're redoing a lobby at 10120 South Riverside, and we had to use the upper lights of glass and the handrail up on the third floor for the new balcony that we created. Had to have bird glass on it, so it's definitely becoming more prevalent. It's just it's so undefined right now as to what is bird friendly, and going way back to Alex, there's really no true spec on it. You know, and like Viracon said this morning, and on a project that we're working on early on, is that, you know, it seems like that what they're being asked to design to is changing on a weekly basis from different spec writers and code officials.
Yeah, I think part of it is also because we're very ad hoc, jurisdiction by jurisdiction, to what qualifies and how it's measured. If we look at New York, like New York City went all in a few years ago with local law 15 that forced bird-friendly materials on all new constructions and all full glass replacements, with no exemptions for single-family homes either, which was just a weird oversight. But they defined a set of good criteria. We're dealing with a project in Evanston where they created their own criteria. Toronto and Ontario created their own criteria. You know, Chicago is kind of coming up with its own criteria. There's no standardization at all about the threat levels that are acceptable, where they need to be placed, what testing is possible. And for example, in New York, there's no accommodation for a registered professional to make any judgments. All judgments are down to the American Bird Conservancy, which, you know, is a difficult lift. It bottlenecks decisions about bird friendly materials to one organization. So I think that's the difficulty, is there's no uniformity at all right now. Although I would like to also say that the province of Ontario just canceled Toronto's bird friendly materials requirements. So I think, you know, to Andy's point, there's no clarity on what's available, what works, and what's going to work 5 years down the line. So I think that adds difficulty to procurement.
Definitely a trend, but a work in progress,
Yeah,
perhaps, for the industry.
yeah, very much so.
Jurisdictions. I'm just gonna kind of move on here. What level of detail and documentation do you guys think is really needed for design intent in glass systems? Just to right off the bat, you know, what are some of the key things that architects need to provide?
I mean, we obviously a model is super helpful. You know, we're 100% in the Revit world, but you know, more importantly, what I typically love, as kind of said earlier, is renderings are key, with some narrative, and a wall section, it would be the kicker. Brendan?
Yeah, I think like really knowing how you want everything to come to the exterior edge, I think is critical to making some of those early systems decisions, and also putting enough information on the table to have Andy tell you, like, no, the 6-inch system is not going to work. It needs to be 10 or what have you. But I also just want to say, having, you know, staring at the project that I spent quite a bit of time on, like, I think being really mindful of how when you're establishing a design intent, and the design intent having color in it, I think being really focused about how you're looking at a glass sample, not just putting it on a desk on a piece of paper, looking at it in a real environment, knowing that it's very hard to look at things inside, and you know, you want to see it in an environment, you want to be able to mock it up with some sort of enclosure that you're looking at the transmission and the reflection, because these triple silver coatings are really tricky. It's not super simple, straightforward. So, and then knowing that there are resources like for the design community, like for projects of a certain scale. For example, Viracon has a piece of their factory wall that they can put in units of your selected coating to review, is one option. I mean, obviously doing a site mock-up is super helpful as well, but I think if we're talking about glass in particular, like just being really mindful of looking at precedent examples, viewing glass samples in the right way. Like, don't try to pick the glass for a building off of a 3x6 sample. And then knowing how to eventually get those renderings to a level where you're close to your intended sample, and then you can communicate to, you know, Alex and Andy, like, hey, these are the things that we're interested in. This is what we want to be doing, and having that kind of doing that legwork up front to kind of help the process go smoother, I think, is one of the critical components.
Yeah, you mentioned a little bit about like making sure sizing too and are accurate, and maybe Alex and Andy can briefly just talk about, you know, when you're, you know, what you recommend for design architects when it comes to sizing mullions or getting an accurate representation of it early on.
Take it, Alec.
No. No, genuinely, I'll let you take the first path.
Andy, do you want
Say that one more time. Sorry.
just talking about you know, what you recommend, you know, for architects to really in terms of trying to size the mullion correctly.
Oh, yeah. Yeah, it's, you know, obviously the mullion sizing is huge, as we talked about a little bit before. So, you know, knowing that spacing and knowing that section view, and then obviously the thermal. So the other component is And again, even if it's even if it's a non-humidified building, still knowing what your outdoor and your indoor is, and if there is any RH, but being able to know what it is deck to deck, again, talking that window wall hybrid, unitized, but being able to get a early structural analysis from a competent engineer to make sure that you're sizing the mullion properly to the vertical and tributary width spacing is huge to the initial design of the building. Because if it gets started on the wrong foot and you start going, I mean, it obviously affects slab edges, it affects your total footprint on decks, cost. I mean, it's a trickle down effect. So that initial mullion, and again, God bless them, but don't always take what you see in the YKK book, Brandon, or the Conair book, and that that little back page where it gives you your 30 PSF. Be careful, because there's corner zones everywhere. There's so many different things to the anchorage makes a difference. So it's huge.
Yeah, be careful just following the standard manual of the wind load charts on the back.
Yeah, it's definitely something that a good facade, for a certain scale of project, it is important to work with a facade consultant, because that's something that you can establish into your basis of design early on, and that helps to start the conversation and coordination process even before you bring on a subcontractor, because some of these, setting the performance criteria correctly really helps to get the facade contractors going. But things like basic sizing and wind analysis and load analysis is something that a good consultant can help you with. Not to toot our own horn too much. But again, it all comes down to early coordination. There are plenty of architects who are capable of doing that, because none of this is rocket science. It's very, very simplistic bits of engineering to get you a good way to coordination.
Also, I know we're running out of time here, and if you have anyone has questions, you can put in the Q&A box. I don't see any right now, so I'll just try to wrap up with maybe just a couple other last minute questions here, and maybe this is a good one to sort of end on. As you're talking about new glass, we can probably talk a little bit about existing glass. Are there anything architects you know about existing glass buildings, and specifically toward their maintenance and replacements? And I'll maybe let Brandon. Do you have any kind of just thoughts about existing buildings and the future of the energy code and reclads and replacements?
Yeah, I mean, I think one of the biggest things is building access. I always think about stewardship, right? When architects ultimately are setting up a set of systems or a set of standards that owners will then carry the building forward and maintain. And so oftentimes a lot of these retrofits, replacements, edits really comes to having building maintenance access, right? That's maybe more than just a couple of davits for a window washer, but having a strategy to replace. I think we should know that we're trying to build buildings, for centuries, and a lot of these glass buildings are so new that I think we are going to want to see, or there will be a delta where we'll be coming back and triple glazing them or changing those facade systems. And so I think that access question really comes to the forefront, because a lot of times it ties into structure, it ties into mechanical, it ties into all these different aspects that aren't just about the needing to replace. I mean, this picture you pulled, Lee, is kind of perfect of one of the challenges with these kind of retrofit projects.
We do have a couple of questions. Thanks, Brandon. That was awesome. Just with some Q&A that came in. So number one, how critical is thermal stress analysis for vision glass and spandrel glass unit? It's
Oh, yeah, it's huge. You know, it's that's what you talk about early on with the with your thermal of your mullions and the size of your glass and the opaque zones. Again, is it humidified? Is it not humidified?
I think the question is to thermal stress, which is actually
Oh,
just the risk of cracking from thermal.
yeah,
Honestly, probably not that critical because generally we don't specify annealed glass on big architectural projects. It's very rare to specify annealed. And most the glass manufacturers will do the analysis, but it's rare that we've switched from heat strength into tempered due to thermal stress issues.
just from my experience, I know that really it's not so much the glass strength itself. I've seen failures in coatings, and I've seen failures in lamination layers due to high thermal stress in spandrel cavities that build up
Yeah.
depending on where where your location and things are. So probably not so much the glass itself, but you got to be really careful about the coatings and like the PVB layers and stuff like that.
yeah. Sorry about that. I misunderstood. Yeah, you're right.
No, I know. I just have the question up on the screen, so
Oh, all right.
thermal stress. But yeah. I mean, it's definitely something we always ask the glass manufacturer to perform anyway.
Yep.
Because they should.
Yeah.
And they're the best
100%.
and they're the best placed to perform that analysis. But to Lee's point, it's not actually most of the time we don't see the glass fail because we
But and again, to that point too, Alec, they're going to need it helps if they have a good detail of what
Yes,
that section looks
you're
like
right.
and what the perimeter is. So what's the section? Is it got a back pan? Is it a shadow box? They're going to want to look at that from a stress value, whether it's heat strength and, again, but yeah, good points.
Yeah, actually, one of the projects I was talking about was actually in higher altitude, Denver and closer to the sun, south exposure, and it doesn't seem like much, but it actually did cause a huge amount of heat to be in the spandrel cavity and caused a couple failures there. The second question: can you elaborate a little bit more on the difficulties in connecting to the structure? Generally, is it easier to anchor to concrete or steel for a curtain wall?
Well, I would say top of slab is the easiest because you can put your embed in on the top, or we can do Nelson studs to a bent plate, and do a box out. But your top of slab is going to be your easiest, and it's going to allow you the shortest distance from face of slab to back of wall. Typically, you want to be 2 inches. If you go to a face of slab anchor, then you're going to be more, again, probably 4 inches from face of slab to back of wall. And then anytime you get underneath, and again, I'm talking unitized at this point. You get, top of slab's easier, face slab's more difficult, further away, and then anything else gets pretty custom. Obviously, you get into window wall, and back to steel or concrete. Steel is much easier. Concrete post tension, as Alec, I think, touched on this earlier, it gets really, really difficult with trying to get embeds in. You sometimes have to muck them in. I mean, it's steel's much easier than concrete, but both are doable. So
Yeah, I would say everything's doable. The biggest issue for us typically isn't what the slab is composed of. It's things like if in a steel construction, you'll typically have spandrel beams, which make installation a little bit difficult. Face of slab to face of column offsets become a problem when you're setting on concrete because you need space to either anchor either side of a column or in front of a column. So actually the biggest issue is what happens behind the face of slab. And oftentimes, if you're jamming a column against the face of slab on a window wall project, it becomes nearly impossible.
Yeah.
So I think that coordination is really key, and that's going to affect how the system is going to work.
Yeah, and that's why I said, concrete's usually, because if it's concrete, you're gonna have a lot more columns than you will in a steel building.
Exactly.
So
Yeah.
you have a lot more of those tough conditions, and that's a great point, Alec, because that's,
Yeah, and then
How about with tolerances too, Andy, it's like
Yeah.
with concrete as well, you probably
yeah.
larger tolerances than steel.
and
yeah,
time.
yeah.
Um,
But at the same time,
Okay.
our shadow box is a good idea.
yeah, our shadow box is a good idea. Should these be avoided due to limited cavity depth between the vision and back panning?
I think shadow boxes are, in my opinion, shadow boxes are a great idea. They're aesthetically by far the best. You could ask, obviously, Brandon what his opinion is as an architect, but aesthetically, performance-wise, they're even better. You can vent the cavity. You typically put a little hole down in the corner that goes into the mullion that allows mullion air to get into the cavity to vent it. And this way you have the entire facade is the same type of glass. So
Yeah, I'd say we have done it both. I've done it both ways. I've done the back fritting on the number 4 surface of an IGU, which with the right selection can work fairly well, but a shadow box is the best from just uniformity look. If you're hiding, you're always going to hide columns. You're always going to have partitions that are acoustically sensitive, hit a wall at a point where you may need to shadow box, and that's a great technical solution to deal with that and keep your design aesthetic.
So in terms
And
of performance,
thermal-
though,
thermal, it's the best too, because the light is coming in and warming that shadow box, where spandrel, you're going to be relying more on the shadow box. And so that having that light get deeper into that cavity warms the mullion in that opaque zone, which keeps a consistent mullion temperature on the going up and down the building.
Alex, any things on this?
No, I think we're good.
Well, we're all in agreement, so I think that's. I'm gonna leave it there while we're on a high note. So
Yeah.
I just want yeah, thank you everyone for attending. Thank you for the questions, and thank you so much for our panelists. I'm just really pleased with your breadth of expertise and what you guys were able to share with our group here. So
Thank you.
Thank you to everyone that
Thank you.
joined. Be on the lookout on AIA Chicago's website for more events, and especially with our technical knowledge committee, we'll definitely have a lot more heading into the new year. So thank you once again, and again, thank you to our panelists. Great discussion.
Thank you for heading it up, Lee.
All right.
Thank you, Lee. That was great. Thanks very much,
Yeah.
everybody. Thanks, Brandon. Thanks, Ed.
Thanks, Alec. Thanks, Brandon.